Welcome back to Tech Talks Education. We are continuing with the atomic structure and chemical bonding. So we had looked at the structure of an atom. What we can say about an atom from inside if we see it. So we had a diagrammatic kind of expression of the structure of an atom, and also we described it in words. Now, let us go ahead and we look at what we call atomic number. Atomic number. An atomic number is always denoted by capital Z. Atomic number. So, we had said that in an atom of an element, we have got the subatomic particles, which are protons, neutrons, and electrons. Let me put them aside here. The subatomic particles, that is protons. We have got the neutrons, and we have the electrons. So protons are positive particles, and each proton has a charge of positive 1. A neutron is a neutral particle with no charge, and an electron is a negative charge particle with a charge of negative 1. So those are the subatomic particles. And remember that the protons and neutrons abide inside the nucleus, while the electrons are found moving around the nucleus in shells or orbits or energy levels. That is what we saw. So let us look at what we call atomic number. Remember this one here, that the number of protons and electrons in an atom of an element are just what? Neutral in this case. But we have to know that there is a problem with the number of electrons, that in some instances electrons are lost, more especially during chemical reactions. So you find that electrons are lost from the last atom, the atom which is, the last shell, which is farthest from the nucleus of an atom, which is called the extranuclear shell or the outermost shell. The shell which is farthest, the last one, the farthest atom, the one which is very far away from the nucleus. In fact, it is what we call the extranuclear shell or the outermost shell. So from that shell, some electrons can be lost in a chemical reaction or as a result of a chemical reaction, and sometimes electrons are gained depending on whether the element is a metal or a non-metal, as we shall see later. So basically, in a neutral atom, protons and electrons are equal in number. Now, we should know that the number of electrons can change, but the number of protons cannot change because the protons are found inside the nucleus and they cannot be what? Lost or gained. That means that unless otherwise some kind of nuclear breakdown or the breakdown of the nucleus or disintegration of the nucleus takes place, the number of protons in an atom of an element remains just the same. It doesn't change. And therefore we use the number of protons in an atom of an element to refer to what we call atomic number. So by definition, which you can be asked anyway in exams to define or to state what is meant by atomic number. So atomic number is the number of protons in the nucleus of an atom of an element. So this is what we call atomic number. But you should bear in mind that the atomic number which is represented or denoted by Z is the same as the number of protons, and in a neutral atom we expect the number of protons to be the same as the number of electrons. So this is a very good and a very important thing that we need to know, that the number of electrons is equal to the number of protons, although in some cases the number of electrons may not be the same if the atom is not neutral, because there can be electron loss or electron gain in an atom of an element. But the number of protons remains fixed or constant, and therefore we use the number of protons in this case to refer to atomic number. So by definition, atomic number is the number of protons in the nucleus of an atom of an element. So we are going to look at what we call the atomic numbers of the first 20 elements. So at ordinary level, we are supposed to know the elements whose atomic number ranges from 1 up to 20. So we call those the first 20 elements. So in this case, we must know that the atomic number is the same as the number of protons in the nucleus of an atom of that element. And we also now take it to be the same as the number of electrons. But when we are defining atomic number, we strictly talk about the number of protons. We don't talk about the number of electrons in this case, because the number of electrons keeps on fluctuating. It is not constant. But the number of protons is ever constant. So let us look at the first 20 elements. So we are having element, and then we have atomic. Let me also look at the chemical symbol, and then atomic number. So let us look at this table here. So we are starting with the first element, which is hydrogen. The chemical symbol is capital H. The atomic number is 1. Next is helium with the chemical symbol of capital H, small e. It is number 2. Then we go to lithium, which is capital L, small I, number 3. Then we have beryllium, which is capital B, small e, number 4. Then number 5 we have boron, which is capital B, as being its chemical symbol. It is having atomic number 5. Next is carbon, which is capital C with atomic number 6. Nitrogen, which is capital N, number 7. Oxygen, which is capital O, number 8. Fluorine, which is capital F and is having atomic number 9. Then number 10, we have neon, which is capital N, small e. It is number 10. So I expect you as a candidate to be able to master the first 10 and the next 10. That is from number 1 up to number 20. So let me use this part here to go ahead and write down the next 10 elements in order of atomic number from number 11 up to number 20. So let's look at this table here also. So we have element, chemical symbol, and then atomic number. So I expect and urge you to be able to practice writing the correct chemical symbols of these elements here and making capital letters and small letters to be completely distinct they should be identifiable, very easily identifiable in this case. Otherwise, if you mess up with the chemical symbol of an element, then you mess up with everything. So, we go to number 11, that is sodium. It has got a chemical symbol of capital N, small a, and it is number 11. Next is magnesium with capital M and small g, number 12. Then we go to aluminium with capital A, small l, and is number 13. Then we have silicon, which is capital S, small I, number 14. Then we go to phosphorus, which is capital P, it is number 15. Then we go to sulfur, which is capital S, number 16. Let me write this number 15 here very clearly. Then we go to chlorine, it is capital C and small l, it is number 17. We have got argon, which is capital A, small r, number 18. Then we have got potassium, double S, not double T, which is capital K, number 19. And then finally we have calcium, which is capital C, small a, number 20. So this is our first 20 elements. I want you to be able to remember these elements here and remember the atomic number of each of these elements here. And you should be able to know that when I say lithium, you just look at the atomic number being 3. When I say sulfur, the atomic number is automatically 16. If we talk of an element with atomic number 20, you know it is calcium. Nitrogen, the one with atomic number 7, you just know it is nitrogen. 3, just know it is lithium. 10, you know it is neon. So, I want you to be able to study this very well, put it somewhere, and practice them. You can even master them in 4s. You can say, let me first master the first 4. Well, then you master the next 4. Well, then you master the next 4. Well, and then you master the next 4. Well, like that. And you find when you have finished all of them, only in 5 goes. So you need to master all of them because it is extremely very important for a candidate in this case. So, this is what we call atomic number. The number of protons in the nucleus of an atom or an element. I don't expect you to say it is the number of electrons. We have to strictly stick to the number of protons, which does not change as opposed to the number of electrons, which changes. And that's what we call atomic number. This is Tech Talks Education. Thanks so much for watching. And please don't forget this. And also don't forget to subscribe to our channels of techtalks.com. Also like it. So we shall continue learning atomic structure and chemical bonding. Keep watching us all the time.